Now, you've identified what are typical Environment Agency caveats. Can you read some of those out to the inquiry, just to give a flavour?
Yes, so the Environment Agency provides a number of different products to developers when they apply, one of which would have been provided to the appellant, and they make various disclaimers in that. And so the Environment Agency's models are only guidance. They instruct that the developers have to do their own modelling. It's that modelling that will take these into account. So, for instance, there's an exclusion on the accuracy of data given that says, so the EA's data is provided without any guarantees, conditions or warranties as to its accuracy. And this is due to the inherent uncertainty in flood modelling, which relies on assumptions about rainfall, river flows and tidal conditions. And I'll come back later on in another question about the inherent uncertainties, because one issue which we'll hear a lot about is our hydrometric stations, and we have three and 4 months. So there's Beeches Mill, which is in Apples Park, Springfield on the Chalmar, and downstream of us there used to be Rush's Lock. There's now no station downstream. And the only station we have downstream on the Chelmer is a human hydrometric station in the form of Barnes Mill, which the next witness will discuss in detail.
Excuse me, is hydrometrics or measuring rainfall or
yeah, so it's attempting to measure flows in the river, and the way this is actually done is, I'll try not to go off on too much of a tangent here, but the way this is actually done, they don't measure the flow. There's no like anemometer like you'd have for wind speed.
Okay.
Right? They measure the height, and based on the height, and they have what's called a rating curve to interpolate what the amount of flow is going through the river. Right? And there are some significant problems with that at Beeches Mill as well. Because Beeches Mill there's floodgates downstream, when they drop the floodgates, it changes the rating curve. So unless that's corrected, that's a massive source of uncertainty. And there are several others we'll go into.
Thank you.
If you could go to the hydrology book, which is at in core document A02, table 7.5.
Do you know what page that is?
Yes, it's page 61.
Thanks.
And it's at the bottom of the page.
It's like that in
61 within the PDF. And it's entitled Commonly Used Data Sets and Their Importance.
Yeah.
And at the bottom of that, could you read out the bit that starts the data type
section I highlighted. This book is written by a guy who used to work at the Environment Agency. It is, as it were, the book on hydrometric modelling, hydrological modelling, I should say. So he says here that various things are important, so like accurate topographic data, but the last one in this list here is historic data, including water levels, photographs, reports, and flood outlines. It says these are needed for calibrating the model. So it's not just about the theoretical models that we see. So the Environment Agency's map is an output of a theoretical model. Now the model may be good, have good physics in it. I don't doubt the Environment Agency's competence to do that, but all models are then as only good as the data you feed into them. And something I'm going to come back to again and again and again is that the data in this location is dreadful. It's absolutely dreadful. So it's impossible to produce a map that is sufficiently accurate to justify building on the edge of a floodplain.
Would you say that the appellants have made full use of these sources?
Could you repeat the question in a slightly different way?
Well, we've identified sources of information that are important for calibration. As far as you were, have the appellants made full use of all these sources?
I don't think so. I think a lot of people take the Environment Agency's maps at face value, as gospel, take it as gospel, as it were. And this is a problem. So Crowder in his book makes it clear that all models should be provided with a clear statement of uncertainty. And if you look, the government's maps, or the Environment Agency's map, published by the government website, has no uncertainty data on it. So you're all looking at these flood zones, thinking, oh, this is zone 1, this is zone 2, this is zone 3, that's where it stops. It's not true. Crowder in his book says, typically on large area models, there's plus or minus 500 millimetres, half a metre of vertical uncertainty. That's in a good model with good data. We don't have good data.
So if you drop down to page 71 in that document, we can see that in table 7.9.
79. Absolutely, yeah. So here he's talking about model accuracy, water level accuracy, by height. In broad scale modelling, this is an acceptable level of accuracy of plus or minus 500 millimetres, and it should be no worse than 750 millimetres. The trouble is, if you don't have the data, you can't even verify that uncertainty. So we're in very unknown territory as to. We have photographs of flooding, but photographs don't even necessarily capture the maximum flood extent. They're taken at an instant in time, which is not necessarily the maximum. So there's a very sparse data to assess the actual, not theoretical, extent of the floodplain.
Could you just read out that sentence below table 7.9? It is also useful.
Yes. So he says here after table 7.9 says it is also useful as a further check to ensure that the model results reproduce the observed flood envelope, that is the extent of flooding on a plan.
Would you say that sensitivity range is significant in terms of the levels that we're talking about?
Yeah, I mean, plus or minus half a metre is huge. If that's what's achievable, I suspect it would be even more than that, and I can go into later why I think that's the case, or I can do it now if you like, which is to do with the topographic volume we have for flood storage, okay? So I've done a rough calculation, and maybe the council has a better calculation. But so floodplain, this part of the floodplain to the west of the A12, which is the active part, what I call the Sandford Basin. This part has different pools. The water doesn't go to one level. If it did, the maximum it could accommodate would be about 24.5 metres, which is the level just before it floods the Army and Navy. And if it did that, and so in a massive flood, it filled the whole of this side of the floodplain up to that level, all of the houses down Sandford Mill and Sandford Mill Road and Brook End cottages, all of those would be well underwater and flooded. Fortunately, it pools at different levels because of the locks. And when you consider this, the volume reduces down from about 10 million cubic metres to probably, and we don't know an accurate figure, probably about 3 or 4 million cubic metres. Now this is an issue because just 1 centimetre of rainfall over a catchment is about 5 million cubic metres of water, and the Met Office are predicting 8 centimetres within 24 hours by 2100, which, if you do the maths, is 40 million cubic metres. 40 million cubic metres is a lot more than 3. So this means there's a significant risk of massive flooding, and just because we haven't seen it does not mean it cannot happen.
So just dropping down from table 7.9, there's a series of bullet points that say calibration is unsuccessful. There's a number of potential sources. Can you just comment on that first bullet, please?
Sorry, can you say that again?
So just below table 7.9,
yeah,
there's the paragraph we talked about, and it says, if calibration is unsuccessful,
yeah,
a number of potential sources of error can be considered. These include, and could you just comment on that first bullet, please?
So it says hydrometric data errors in stage, date and timing and rating curves. Okay, so yes. So I'm extremely familiar, as the appellant should be, with the data available from the Environment Agency for each of the hydrometric stations. And the data that's available isn't just numerical data, so this is catchment daily rainfall is 1, and something called GDF, which is the gauged daily flow, which is the average flow in cubic metres per second throughout that day. It's an extremely useful number. And so if you multiply that by the number of seconds in a day, you can work out the volume of water according to that gauge that's flowed through that station. But if you look at that data directly, you will see that every time it floods, because of Beech's Mill, there's the level of Beech's Mill, when the water level reaches 2 metres, there's a spillway before the hydrometric station which guides floodwaters out over the side and it floods out in this park. Okay, so this means that all of the water that exceeds 2 metres is not measured. Okay, so any volume calculations you make based on GDF are all minimum figures. And so the issue is most of the water that's coming in during a flood is not measured. So if you're not measuring it, there's no physical possible way to make an accurate assessment and calculation of the flood maps.
Just to be clear, just to understand your point, Mr. Parker, so you say when it reaches 2 metres, is that the depth of the river or the depth of the channel?
Yeah, it's the gauge height at that station, which I assume is on the upstream side, would be the height from the bed, the riverbed, up to the top of the station before it overflows.
And so when you're saying when it gets to 2 metres, any excess water is...
Yeah, it spills over the side. There are some photographs in my thing of that. Would you like me to find them?
I think I can probably find, I can sort of visualise what you mean.
Yeah, it literally, I don't know if you've ever seen the photos of Admiral's Park in flood, but the whole area, I mean, it shouldn't really flood. It's basically, it's decades and decades and decades of development in the west of Chelmsford before anybody thought about sites or anything like that. All pours surface water off down into the valley and it floods it because of the bottleneck through the city. Okay. But yeah, so when it gets to 2 metres, it just pours water over into the park, all over the
like
footpath.
a bathtub overflowing or
Yeah, like an overflow bathtub, exactly.
okay. Thank you.
Mike, do you have any indication of the extent of the overflow water? Is it tiny? Is it a metre or do you just not?
The indication I have is that so overflows at 2 metres, the highest I think I've seen on the record is about 2.7 metres. I think, I'd have to check that for you. I think it's about 2.7 metres, but let's bear in mind that the width of the channel, as it were, increases as the height goes up, okay? And when it gets over the maximum extent of the rating curve of that station, and it starts overflowing, that width becomes huge. So every 10 centimetres that you gain above that actually takes a larger and larger volume of water. So when we're seeing 2.7 metres, that could easily be the same amount that's in the channel normally. Again, so we have no idea of the amount of water that comes through that station.
So that's just because the water's spreading out, isn't it?
Exactly.
Before I move away from this document, can you just drop down to page 76, please? It's kind of the bottom of 76, top of 77. I might be the bottom. And the heading is level of uncertainty and understanding. So
Yeah, go ahead.
can you just read it out, please?
Okay, so this is from Crowder again. So he says, depending on the stage of the design process, the user of the model outputs will require different levels of accuracy and understanding. At each of these stages, it's important to communicate an understanding of the uncertainty in model outputs, as in some cases, this can alter design decisions. Inherent in this is a need to understand the limits of the model and what it is and is not capable of doing. So I would say this applies to the appellant's modelling, but it also applies to the Environment Agency's modelling. And at the moment, the Environment Agency is able to put out these flood maps, which are treated as gospel by councils and planners and developers. It's putting this information out with no uncertainty data, which is extremely misleading.
So as far as you're aware, has any understanding of the uncertainty in the model been communicated by the appellants?
I haven't seen any. I'm sure they can answer that.
So my next question do relate to the monitoring stations. You've already described them in part. This is in your section 7, analysis of hydrometric data. Can you just comment on the 3 monitoring stations without repeating yourself from before in relation to Rushers Lock, Springfield Station and Beecher's Mill?
Yeah, certainly. So Springfield's quite a good station. The Chalmo actually, although it inherits the name downstream, there's actually less water comes from the Chalmo than comes from the can. So that's a good station. I've already mentioned the problems with Beecher's Mill, and that's serious problems. There's a station at Whittle, but not a huge amount of water comes through Whittle, and we also don't see the increases that I'm probably going to get onto later on. In fact, I'm going to spend a lot of time on later on. But that's also quite a good station. And there used to be downstream one at Rush's Lock, so this is just before you get to Alton, and there's a weir there. That wasn't a very good station either, because that also suffers what's called bypassing. So what I described at Beecher's Mill is known as bypassing, so where the water doesn't go through the station. And that was disbanded in 2010, which means, this means so we live in a city that is built on wetlands. It has 3 rivers coming in, 1 river going out. Right? And it means the river going out, we've got no measurement of the water flowing through it. What the river that most of the water comes in, the Can, we've got no reliable measurement because it's inaccurate over 2 metres. So we've only got one good input to feed into this model. And so there's no way in that scenario you can actually tune the model to get any accurate outputs. It's just not possible.
So you summarised, if you like, the changes in the data sets over time. In 7.2.5, you deal with Rushers Lock. Can you just read out that last sentence, please? In the latter case, 7.2.5.
Yeah, 7.2.5 said, in the latter case, the number of days increased from just 3 in the 1970s to 29 in the 2000s. It's in the extreme flows which are increasing the most. It is the extreme flows that are increasing the most. I'll spend a bit more time on this. I'll draw people's attention to that figure, so figure MJP24, if you flick to it.
And just refer to the graph, so it says 3 in the 1970s. Is that 3 per year in the 1970s?
So in the 1970s, in the whole of the decade of the 1970s, there are only 3 events like this. And to describe exactly what my data shows here, so because of the size of our catchment, it takes a finite amount of time for rainfall at the edge of the catchment to reach here. Right? And so that means it could rain a few days ago, and then we see a surge in the river here a few days later.
Okay.
So to smooth out that, I integrate over 3 days, and that gives us smoother data to analyse. And when you do that, so when I integrate over 3 days, what that gives me is the volume of water flowing through that station or over that weir over a 3-day period. So what I do is I count the number of days where that exceeds a certain amount. So if it's a small amount, like 1 million cubic metres, you don't see a trend. But let me just find that figure and we
can see. Is this MJP24?
MJP24, yeah. So this was the first station I've analysed data for. I've subsequently done the other ones in preparation for this appeal. But when we look at this data, what you see is when you look at the lower numbers, on here I've only put 4 of them, and so if I started with 2, you see there's no trend. Right, so on 2 million cubic metres, no trend. 3 million cubic metres, you start to see a bit of a trend. It increases from about 100 to about 140 or something. 4 million cubic metres, it's a larger trend still. It increases from about 3 to about 65, something like that. And if you look at the most extreme events of all, the ones that are most dramatic for flooding, 5 million cubic metres, that increases from only about, what did we say it was, 3 or 4 days in the 1970s to almost 30 days in the 2000s. It's a huge increase. I have sent this analysis to the Environment Agency and looking to schedule an opportunity to discuss it with them, because we're seeing this problem not just in Chelmsford, we're seeing it all over the country. There was a study by Hannaford a few years ago where he was looking at peak flows, which is a slightly different measure, but again, he identified these massive increases decade on decade across the country. And this is a different form of analysis that has the same finding, essentially. And the interesting thing with this, if I direct you now to the newer analysis I've done for the other stations, you see Springfield shows the same sort of thing, although it's not so dramatic. And I think the reason it's not so dramatic is we've only really just started developing up there. Okay, so Bewley Park, Channels, these major developments are still quite new, so we're yet to see in the decadal analysis the changes from that. Writtle, which is MJP 20, no, which is now
27.
Thanks. Yeah, MJP 27. This is very revealing. Okay, if you look at MJP 27, the station at Writtle shows no trend whatsoever. There's a very obvious reason for that, which is the wind flows through Greenbelt, so there hasn't been a significant amount of development around it. So we don't have the problems with increased runoff on the wind. So I attribute that as the most likely explanation for the lack of that trend here.
And then just a summary for Beeches Mill in terms of the change.
The summary for Beeches,
yeah.
You'd like me to describe?
No, just your last sentence on 7.2.9, the summary of what's changed at Beeches Mill.
Oh, okay, thank you. Yeah, so my final sentence on that said that at this stage in the 1970s, VF3D, which is my name for this integral over 3 days, so it's the volume of flow integrated over 3 days, exceeded 4 million cubic metres on only 3 days, which increased to 24 days in the 2010s. So you see, that's very similar to, so this is upstream of Chelmsford, that's very similar to what we saw down Rush's Lock. And this is because Beeches Mill really dominates. So the CAM, that combination of the wind and CAM that flows into Chelmsford, there really dominates on the amount of water flowing into our rivers during flood conditions.
Isn't this just due to increased rainfall?
No, as far as I can tell, there is no increase in rainfall. So I did exactly the same analysis using what's called CDR, which is catchment daily rainfall. So this is all of this data, as I'm sure the appellant knows, is all available from the NFRA, the National River Flow Archive. I think I said that the wrong way around. NRFA, and you can download GDF and CDR going back years and years and years. And if you do exactly the same form of analysis, Russell, which of my pieces of evidence was that? The rainfall one? It's in here somewhere.
I don't need to take you to it. I just really think you could explain to the inquiry what your findings are, please.
Yeah. So my findings for rainfall was there's no such trend. I'm just looking through it myself. Oh, okay. Slow down, Max. Slow down.
So you
okay. So it's I'll finish the point. So MJP 21. Was the analogous analysis applied to rainfall. So if you look at MJP 21, 22, yeah, so if you look at MJP 21, you'll see that some of them are a little bit up, some of them are a little bit down, but overall there's no trend. And what we definitely don't see that we saw in the others, which is worrying, is that as you increase the number, as you make your cut-off, your threshold higher and higher and higher, the trend gets greater and greater and greater. That's what we saw on the hydrometric data. We don't see that here. So this is very revealing as to what's going on. So saying it's not it's not rainfall that's increasing, it's something else is causing the increased flows in our river, and it's fairly obvious to see what that is.
Thank you. So in section 8 you look at flooding timeline, you take a series of high water events, you correlate that with hydrometric data, and then you correlate it with photographic evidence.
Yeah.
And what you're trying to do here is establish a flood level at the appeal site, which is your 8.2.11, where you say, I determined that the flood level for this modest flood was approximately 22.3 metres.
Yeah.
And I've mapped out the approximate flood extent across the site. So this is one of those cases where the actual illustration of that is in the original document. So if we could just flip to CD 8.02, page 8, we see this plotted on the appeal site. And I'll just ask Mike to talk to that.
Yeah.
I've got that. Yeah.
Okay, great.
So just to clarify,
yeah.
this is page 8. There's a photograph at the top, and then there's a plan below. This suggested location for the lighthouse, that's just your sense of humour, I presume?
Yes, I wasn't intending to bring this photo to a planning inquiry.
Okay, thank you.
That's how it happened.
So you're happy that taking all the variables into account and correlating various data sources, that this is an accurate representation in these high water events?
So basically what I've done is I've used the photographs that I could find. So there's this photograph above and there's drone footage, and use that to identify that, okay, the water level during this flood falls roughly halfway between the trees on the north, the trees to the north and the hedge to the south. I then did an overlay using the appellant's topographic map, which is very helpful, thanks guys. And then from that, I was able to assess that it falls somewhere between the 22 and 22.5 metre lines, elevation lines. Because if you look at the 22.5 metre line, that's right up towards the trees at the top, which we can see it's not that high. It's somewhere in between. So I sketched that out and said that in between that falls at about 22.3 metres.
Are there any water level sensors on the meter?
No, I have contacted, I think it was the Environment Agency, I might be mistaken there, but I contacted one of these organisations to request that they install one there, because this is critical. So,
What's the level?
yeah, the closest one we've got is at Beaches Mill, and even the level data on there is reported as suspect, and we're going to come to this point, I think, but a lot of this data is reported as suspect, and obviously this is much further upstream. We have no idea from actual measured data what the level is on the meads when it floods.
Can you just explain that point about suspect, where that comes from?
Yes, I can, and I'd love to direct you to the Environment Agency website, but I think it would take too long. But what I do have in my evidence, if we scroll to, let me just find the reference. One moment, I'm just going to scroll down and find it. Where is that? Bear with me, I'm just trying to find it.
If you can't find it, it's sufficient just to explain the suspect annotation.
I think it's important to show people. small number there now. Yeah, 3, do that. If anyone else is looking for it, it's a print screen of the spreadsheet in 8.02. But basically, I'll talk through it at the same time. But so in this data, the CSV files that you download either from the NRFA or the Environment Agency, you have one column which includes the numerical value, and there's another column with a quality field, right, which says how reliable that data is. And what I found doing my analysis, and I would have thought the appellant should have found as well, is that every time it floods, if you look at those data sets, GDF and level, you see that next to it puts us a quality notice where it says that data is suspect. Now, if that data is suspect, you can't then use it to claim that you can make accurate and analytical predictions of flood extents.
So apart from the hydrometric stations, there's no water sensors in the meads. You just do the best you can with the data, look at photographs. That's the approach of it.
Okay, so the page you need to go to is page 80. It's always helpful to see an example. So
Page 18, sorry, your proof.
yeah, if you go to page 80 in 8.02.
Okay.
Sorry, it's going to be so long to find that. It's 374 pages.
Yeah, I'm there.
Right, so if you scroll down there on on the 14th and 15th of January 2021, which I know is the dates that the photographs were taken for that flood extent are calculated or derived from photographs. And you'll notice that on the 14th and 15th, if you scroll across to the column below where it says Table 1, it says LD max status. Okay, so that status field has been inherited from the CSV file from the Environment Agency, and you'll notice it says complete suspect. So that's actually a combination of two fields that are given in that thing. So the quality of that data, the measurement was complete, but the quality is suspect. So this means every time that it floods, which is the time that data is most critical for flooding analysis and this, every time it floods, that data is suspect.
Thank you. In 10.3, you provide photographs that show that the site is flooded.
Sorry, Mr. For the microphone.
Sorry. Yeah, in 10.3, Mike, you've identified that the site has flooded in the way you just described.
Yeah.
4 times in 6 years. Were those extreme high water events? What was special about it?
No, definitely not. So the floods we've had in recent years have all been modest and mild, and the reason is El Nino. So if you've heard of ENSO, so it's the El Nino Southern Oscillation. This is a climatic oscillation you get in the Pacific Ocean, and when it can cause it to be either dry, or it can cause hot and dry, or cold and wet. So La Nina is cold and wet, and what we find during La Nina, that puts a lot of moisture into the atmosphere, which comes across the Caribbean, gets caught in the jet stream and brought up to us. So what we see is a correlation between when we get the bad floods here and the strength of La Nina. And so in recent years, whilst it's been La Nina, it's been a fairly mild La Nina. So I'm expecting the bad floods to return when we get a strong La Nina. And one of the worrying things about climate change is that the strength of the El Nino Southern Oscillation is getting greater. So the potential here, especially when I highlighted those numbers about we've got 3 million cubic metres of storage on the floodplain, which we're chipping away at all the time, and this development would chip away at it more. And we could get potential for like 40 million cubic metres that get stuck by the A12 and can't get across. So it's kind of, I'm here, sounding the alarm.
Mike, if we could look at core document 1.63. So this is the FRA, and then on the back of it there's hydraulic modelling by Royal Haskinen, and it's figure 3.1 on page.
Can you give me a bit of help to find that document? Is it in CD 1.01?
Core document 1.63.
Must be, yeah.
It's page 40 of 50.
1.63.
Is this the hydraulic modelling?
Yes.
It's a separate report within the...
It is, yeah.
Yes. Okay, yeah, I know the picture.
And then at the top of page 40 is figure 3.1.
Yeah, very familiar with this figure.
So this is a baseline model created by the appellants. It includes 1% annual exceedance probability plus climate change, and so it's there to describe a 1 in 100 year event. Mike, how does this plan compare with your line at 22.3?
It's essentially identical. The brown outline on this, incidentally, I should explain. So the reason for the difference in the shape of the blue outline and the brown outline is not so much the model output, it's that the appellant used a different topographic model when they did this. It's a more up-to-date and I think probably more representative of reality model. I don't think the ground is as uneven as the blue outline suggests, certainly from the flooding photos that I've seen. So I don't doubt the physics of the appellant's model of the contractor. I think their physics is probably fine, but again, like the Environment Agency, all of these models get tuned to the data that you've got, and if there's garbage in, garbage out, and this is the trouble. The physics can be good, but if the data's bad, you haven't got hope.
So you're saying that the appellant's 1 in 100 year scenario is synonymous with your 4 in every 6 year scenario?
Yeah, it's characteristically identical. I mean, the difference is academic.
So rather than a 1% probability, by your observations, it's actually a
60 or 60, 70, whatever it is.
Thank you.
Yeah, and this is the trouble. And the other trouble with these, and certainly I think the new, I may be wrong, but I think the new government maps, they don't even seem to show the top level of flood risk, right? So it's like, okay, it's every 30 years, but there are areas of that floodplain that flood basically every year. They should be, so planners, they talk all the time about flood level 3B, right? So is it 3 or 3B? And then 3B is functional floodplain. But functional floodplain should be shown on the Environment Agency's maps. If there was an outline for 3B shown on the map showing this site, it would be obvious that that a large part of the southern end of that site is actually 3B. It's not flooding once every 30 years or every 100 years, it's flooding almost every year.
Can you go to document CD 15.07? That's it's just a useful plan.
Sorry, the microphone again, Mr.
Oh, sorry, I'll keep switching on.
Was that CD 15.07?
Yes, that's correct. And these are basically the plans I use for sequential tests, but I just think it helps to point something out.
Excellent. I can point something out in this as well.
So this shows the river, it shows the built, and I want to direct your attention to the peninsula land. Can you just explain to the inquiry what the peninsula land is?
Yeah, so in my evidence, you'll see this called Wharf Road, which is named after one of the roads that runs through this peninsula. But so the peninsula is between the river and the canal that goes up from Springfield Lock, that dead leg of the canal, as it were.
So it's just outside the red line on this plan?
Just outside the red, yeah, on the left-hand side there. And this area where the gasworks originally was, historically that floods. There's some fabulous photos from the 50s of the whole area underwater, and there's someone's car that's been stranded, one of these old-fashioned cars stranded in the middle of it. So all of that area is part of the floodplain. Whether we include that in an outline that we draw on a map or not, it doesn't matter. In physical reality, it is part of the floodplain. And now that's all been developed and it's not allowed to flood anymore, that's like a double-edged sword. That causes two problems. One, all of that runoff has nowhere to go but onto the floodplain, because there's no suds, I don't think, for any of that development, nor could there be. There's nowhere to put it. So that's one side of the sword. The other side of the sword is it's a massive lump of concrete in the middle of the floodplain, which is lost storage, which we really can't afford. Now, I've no objection to the council developing that area. I think it's a sensible area to build, but you've got to offset that. Right? If you're going to take a big chunk out of the floodplain, which is already too small, as I've highlighted, then you need to offset that by increasing capacity elsewhere. And I think we're going to come on to the bottlenecks in the system, but this isn't. When we get to that, there's opportunities to increase capacity.
Another plan on the same thing, CV 50.08. So this is the overlay of the floodplain on the proposed works to the Army and Navy roundabout.
Is that the right reference? Is it C?
It's 50,
Oh, 50, yes, sorry.
Is that page 2, Russell?
yes, page 2 of 8. Chair, 10. Yeah.
Thank you, sorry, yeah, that's all.
Same question really. How does the proposed work to the Army and Navy relate to?
And the same answer. Again, I can't object to the council trying to do something about that roundabout. Obviously, we need something. But again, if you're putting concrete and tarmac all over this part of the floodplain, one, that's going to increase the runoff into the floodplain, and two, it's a loss of floodplain storage. And so again, that needs to be offset. So what part of me being here today is not just to challenge this application, it's to highlight to the council that there's a really serious problem we need to get to grips with, and to try to get the council to start working with us to understand the problem so that we can figure out what to do about it, because you can see the potential for some, almost biblical level flood when you look at the numbers, and so, we need to avoid that. We've got an opportunity to avoid it, so let's do so.
Thank you. In section 5, you talk about bottlenecks. You've identified that we're getting larger volumes arriving more quickly. So what happens when water hits the floodplain? How does it spread out? What the bottlenecks, and how does that affect flow?
Okay, so the important thing to realise is that the gates we have are flood gates. They were built as part of a flood alleviation scheme, even though the Environment Agency tries to wind that back and call them sluice gates as a level control structure. They are flood gates. It's the reason they're so much wider than anything on the river. And when those gates drop, if they drop suddenly, you can literally get a tidal wave out on the river. And people have seen this in 2000. This was after they wrenched one of the gates out. But if the gates open suddenly, you can literally get a tidal wave. So for anyone who lives down river on the floodplain, this is really bad. Probably the most vulnerable is Graham Pesquet in the bottom.
Sorry, can I stop there? I really want to understand when water arrives at the floodplain, and it hits the bottlenecks. Can you explain how the water is affected?
That's what I'm kind of getting there. So there's several bottlenecks on the floodplain. One of them is at Sanford Mill. So where is the floodgate and shelter is something like 25 metres wide. That's just a number I've measured off of Google. The ones at Sanford Mill are something like 10 metres wide, right? So 2.5 times less, despite this being the same river. So obviously that's the bottleneck. Obviously it overflowed at Sanford Mill, and then all that water comes spilling past Mr. Pesky's house, and he's got a flood barrier built, a bund built around his house, and we'll come to this later.
When it comes up on the building, just before we finish, can you deal with the A12 bypass?
Yes. So the second bottleneck, which is even more serious than that one, is the A12. So the natural opening across the width of the floodplain there is something like 800 metres. Right, but when that A12 was built, or the Chelmsford bypass as it was called, which I think was built in about 1986, when I would have been 1, when that was built, it should have been built on pillars, on stilts, like the original A12, so like the Chelmsford Valley Bridge that we've got now. But it wasn't. They went for the cheap option and built a solid earth embankment along most of it. And then there's one little opening around the river, which is approximately, from Google, about 70 metres wide. And then further south, there's what I call a storm drain, which is probably 10 foot in diameter. But for reasons that are entirely elude me, whoever designed it put a massive, great big concrete wall in front of it. So water can't even flow into that storm drain until it's too late. And I think if we got surveying to look at the height of that concrete wall and the height of Mr. Peskett's flood defences, we'd probably find that concrete wall is even higher than Mr. Peskett's flood defences. So if I was him, I'd probably try to sue whoever built the A12.
So the aperture of the A12 bypass has reduced from by about 90%.
Yeah, from about 800 metres down to about 70. So.
And how does that affect the way water moves in a high water event?
Well, there is a video which I made. So last time it flooded, we went down there and took a video, and I walked around on either side of the A12. I went under that 70 metre opening, filmed on one side and the other, and I'll find the pictures for you in a minute. Let me find those now, because a picture speaks 1,000 words, as they say.
So MJP 17 and 18.
MJP 17 and 18. Thank you very much. Yes. So these are stills from that video. The video's more fun, but the first of these, shows the west side of the A12, what I call the Sanford Basin. So you'll see this here looks like the sea. It's totally underwater. Whereas if you flip to B on the next page, this is on the other side. Right, so this is on the first day of the flood. Right, so what this bottleneck of the A12 does is it's like a valve. It doesn't prevent water flowing there ever. It just delays it. So it holds it back transiently, which allows the level on the Sanford side to build up. And what you can see here is that whilst one side looks like the ocean, the other side is almost completely dry. Whereas in nature, the floodplain, it could spread out right across there, and it can't do now. This, incidentally, is one of the other ways that we know that the Environment Agency's flood maps are wrong, because if you can see that the eastern side is dry, whereas the western side is flooded, majorly flooded, that should manifest in a difference in flood zone probabilities on either side of the A12 on the flood maps, and there's no such difference, which shows that dynamics were not taken into account on the Environment Agency model, so no clue that it's wrong.